Graphs of other circular functions. First, we're going to look at the graph of the cosecant and the secant functions. Now remember, the cosecant values are reciprocals of the corresponding sine values. In other words, the cosecant of an angle is 1 over the sine of that angle. So if the sine of x is 1, the cosecant of x is 1. If the sine of x is negative 1, the cosecant of x is also negative 1. When the sine is positive, then the cosecant will be greater than 1. Because 1 over a fraction is going to give you a number greater than 1. 1 over a fraction between 0 and 1. Similarly, if sine is between negative 1 and 0, then the cosecant will be less than negative 1. When the absolute value of sine gets closer to 0, the cosecant, the absolute value of cosecant, gets larger. The graph of y equals cosecant of x approaches the vertical line x equals 0. In fact, the vertical asymptotes of the cosecant function are the lines x equals n pi. In other words, at pi, 2 pi, 3 pi, 4 pi, you're going to have vertical asymptotes for the cosecant function. Because remember, the cosecant is going to be undefined anywhere that the sine of x is 0, and that's going to be at multiples of pi. Now we can look at the secant function in a similar way. We can look at how it's the reciprocal of cosine, and we can look at where its asymptotes are. It's the same analysis. You're going to have asymptotes anywhere where the cosine function is 0, and the cosine function is going to be 0 at those odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2. All the things we just said about sine and cosecant are essentially true for cosine and secant. So here we have a graph of the sine curve in the red dotted curve, and then we have the cosecant curve put with that, and you can see how the sine and the cosecant are equal at 1 and negative 1. You could see that there are asymptotes for the cosecant function where the sine is 0, and you could see how they kind of go in opposite directions there. Here's a similar graph, but this is for cosine and secant, and again you can see that when the secant and the cosine, they're going to be both 1 or negative 1 at the same spots, and you're going to have the asymptotes for the secant graph where the cosine is 0. Okay, so summing up the cosecant function, it is discontinuous at values of x in the form of x equals n pi, so 0, pi, 2 pi, 3 pi. It has vertical asymptotes at these values. And again, those are the values where the sine is 0. There are no x-intercepts. It will not come in contact with the x-axis. It has a period of 2 pi, but it has no amplitude. And like the sine function, it is symmetric with respect to the origin, which means it is an odd function. The secant function is discontinuous at values of x in the form of pi over 2 times 2n plus 1. Now that translates to the odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and the negatives of those, which are the places where the cosine is 0. It has vertical asymptotes at those values. It also has no x-intercepts. It has a period of 2 pi, just like cosine, and no amplitude. It is symmetric, again, like the cosine with respect to the y-axis, which makes it an even function. Graphing, these are some guidelines to help you sketch the graph. Know that you're probably going to use your calculator to help you with that, and that's fine. But remember, we want to make sure that the graph that we put on paper is as accurate as we can, reasonably accurate as we can make it. So we're going to graph their suggestions are, step 1, graph the reciprocal function to use as a guide. So if you graph for a secant bx, if you graph the a cosine bx, that gives you a guide. You can plot the asymptotes from there, and you know that they're going to meet at the high and low points. Do the same for cosecant, you'll use sine. Sketch in the vertical asymptotes, and then put in the high and the low points, and then you can sketch the different branches and the U-shapes. So we're going to graph 2 times secant of 1/2 x. What I want you to do is graph 2 times the cosine of 1/2 x and then overlay that with the graph of secant. Pause this recording, give it a try, and resume to check your answer. Okay, so we're going to graph y equals 2 cosine 1/2 x, whichever method you prefer for doing that. Go ahead and use that. You can see here they're giving you the key points and how the intervals divide. And then you see on the left the graph of 2 cosine 1/2 x. They're putting in the asymptotes there. And then you can see how the secant graph is laid over that in figure B. And this is just completing the description. Now tangent. Tangent's a little different. It has a period of pi and no amplitude. Its values are 0 when the sine is 0, because remember the tangent is the sine over the cosine, so it's also undefined when the cosine is 0. This is what the graph looks like, very different. It is, again, periodic. It has a period of pi, but it has no amplitude because it continues in the positive and negative y direction without ending. As x goes from negative pi over 2 to pi over 2, the tangent values go from negative infinity to infinity, and that would be one cycle. And the x-intercepts are going to be in the form of x equals n pi. In other words, the same places where the x-intercepts are for the sine curve. The cotangent period is pi, just like tangent, has no amplitude just like tangent, but remember it's the reciprocal. So now our values are going to be 0 when the cosine values are 0 and undefined when the sine values are 0. And there's the graph of it. You can see it looks like it's the tangent, except it's been flipped and moved over. As x goes from 0 to pi, the cotangent values go from positive infinity to negative infinity, and it's a decreasing function, which means from start to finish, it's going down in one cycle. And the x-intercepts are going to be in the form of 2n plus 1 times pi over 2. In other words, the x-intercepts are going to be in the same places as the x-intercepts for the cosine function. And again, our asymptotes are going to be at values of pi, so 0, pi, 2 pi, 3 pi, and the negatives. Okay, here's some guidelines for sketching the graphs of the tangent and the cotangent. What they suggest you do is the period is going to be pi over b. Now remember, for sine and cosine, the period was 2 pi over b. That's because for sine and cosine, the original formulas, the original functions, the period is 2 pi. For a tangent and cotangent, the period is normally pi. So if you have something in front of the x there, the period is going to be pi over b. So you want to find the period. You want to locate the two adjacent vertical asymptotes by solving the equations for x. So you're going to do that bx equals negative pi over 2 and bx equals pi over 2 for tangent, or for cotangent, bx equals 0 and bx equals pi. Those will give you the two vertical asymptotes, and then you can divide those into 4 equal parts, like we did for sine and cosine, and then evaluate the function at those parts, at the first quarter, the midway, and the third quarter. And the midway should be where it's crossing its axis there. Join the points with a curve, approach the vertical asymptotes, and then just reproduce those additional periods as necessary. Okay, so let's try an example. You're going to graph y equals tangent of 2x. Follow the steps, pause the recording, give this a try, and resume to check your answer. Okay, so the period of tangent is pi over 2, and what we're going to do to find those two asymptotes is we're going to do 2x equals negative pi over 2 and 2x equals pi over 2, and that gives us negative pi over 4 and positive pi over 4. So you're going to sketch those in. We'll have a graph of that in a minute. And then you're going to divide that into 4 equal parts. So it's going to be, you're going to have a point at negative pi over 8, at 0, and at pi over 8. And then just evaluate the function for those to get the y value. And plot those on the graph, you see here. And you also see how it's going to look on your calculator. Now try it with a cotangent. Pause the recording, give this a try, and resume to check your answer. Okay, this time we're going to do 2x equals 0 and 2x equals pi. And that's going to give us 0 and pi over 2 for our asymptotes. So we're going to sketch those in. And then we're going to divide that into 4 parts. So pi over 2 or 1/2. If you cut that in fourths, you're going to have eighths. And so we're going to have a point at pi over 8, pi over 4, and 3 pi over 8. You could put those in the function and find the y values, plot those on the graph, and sketch it. And now we're going to try another graph. This one's a little more complicated. We've got some shifts going on here, but using what you know, pause the recording, give this a try, and resume to check your answer. Alright, so in this case, b is 1, so the period is pi. We don't have anything multiplied by the x, so the period hasn't changed. Now we know that it's going to be translated down 2 units, and it's also going to be translated right 1, and it's going to be reflected across the x-axis. That's the negative sign in front of the cotangent. So we've got a lot going on here. To locate the asymptotes, we're going to do x minus pi over 4 equals 0, and x minus pi over 4 equals pi. And we're going to solve for that, and we get that our new asymptotes are at pi over 4 and 5 pi over 4, and that takes care of our shift, our phase shift. So we don't need to worry about that anymore. We know where those asymptotes are. We're going to divide the interval into 4 parts, just like usual, and we're going to evaluate the function at those key values, and doing that actually takes care of our other concerns. It takes care of the reflection, and it takes care of the vertical shift. So you can see that we've plotted those points. C equals -2 becomes our new 0 line that the function is being graphed around, and you see the completed graph there. Now we're going to do something a little bit different. We're going to find an equation for the graph. So this time you have the graph, you need to find the equation for it. You need to decide what kind of graph it is, which function, and then you've got some points plotted there. You've also got the asymptotes, and you need to make a decision about, has something been done to change the normal asymptotes? If so, what? And has this thing been shifted at all? So pause the recording, give these a try, and resume to check your answer. So for A, the graph is the graph of a tangent. It has been reflected across the x-axis and stretched vertically. And so what we have is an equation of y equals -2 tangent x. The -2 is the reflection, or the negative is the reflection, excuse me, and the 2 is the vertical stretch. One thing you can do is you can take an equation, once you know it's a tangent, y equals a tangent bx, and you can put the points in there. Now we know that the period wasn't changed, so the b is just going to be 1, but you can put one of the points from the graph in there and discover what that number is, and that's what was done here. For part B, it's a cotangent function. The period is pi over 2. You can get that from the graph. So we know that the coefficient of x is 2. How do we know that? Period for a cotangent is pi over b. So pi over 2 equals pi over b, so b must be 2. We can also see from the graph it's been translated down 1 unit, so that's going to be a -1. And then again, once we know those two items, we can, if we need to, if we think there's something being multiplied by the cotangent, we can try out a point that's indicated on the graph and solve for that value. In this case, there is no horizontal stretch or shrink to this graph, so there's nothing in front of the cotangent. All right, let's try this one. These are not tangent and cotangent, so we're back to secant and cosecant. You need to determine which each of these is, and you need to come up with the equation for it. Pause the recording, give this a try, and resume to check your answer. All right, so for A, we know it's a cosecant, and we know that it's been stretched horizontally because the period has changed. In fact, the period is 4 pi. Now, remembering that the period for secant, cosecant, sine, and cosine, to find the period, you do 2 pi over b. So if we know the period is 4 pi has to equal 2 pi over b. Solving for b, we get that b is 1/2. So we have the cosecant of 1/2 x. For part B, we have a graph of secant translated 1 unit up, and that's all that's been done to it. So you're just going to add 1 to the secant of x. The rest of this recording is additional practice, so if you will try these problems, pause the recording while you do them and resume to check your answers.